Now, if object is here, object, what is the condition? Object is placed in rare medium facing the convex surface. Look at the boundary. The boundary is a convex towards the rare medium. Let's assume that this is a rarer, this is a denser. So the incident ray, this is a boundary. Boundary will, so like this normal will indicate here. Already just now I discussed that I'm summarizing it. So we will get the, this is the thing. It can, and this is the image. Okay, this is the incident ray. Now it can happen a situation where object kept in rare medium, the image is formed in denser medium. That's what you're seeing. Now I can bring a situation where still it is a denser. The ray will undergo refraction and it will bend slightly. Now the ray, it will bend slightly. It will not bend more, it will bend slightly. Get that one? So where the image, I think I'll bring it here. We'll extend this line backward. So look at the image formed. So here is what? The image. Hope everyone is getting, this is center of curvature, this is P, this is M. What we had the discussion, no, it can happen. So still that formula is very much applicable. Look at the image. Earlier the image was in denser medium. Now where the image is in again that medium. Object and image can be in both in same medium. Instead of bending more, the ray will bend slightly. It all depends on the value of mu2, mu1, and also the object distance. Now we will have a situation where, let me select this part. Yeah. Now I'll keep object in denser medium. Let this be the object, and this is the radius of curvature. Normal, this would be normal. Now the ray will be incident. Now the ray is moving from denser to rarer. So it will bend away from normal. So after refraction, the ray will meet here. So now where is the object? Object is in denser medium and the image is in rarer medium. That pink color dotted line is the center of color. This is normal. Okay, this is the thing. So now I'll bring another situation here. Now, the ray is moving from rad to denser. It will bend slightly. It should bend away from normal. It should bend away from normal. Okay, then. Slight correction. I'll make it. This is one more situation. We may end up like this. Now the ray is moving from rare to denser to rarer. So it should bend away from normal. It should bend away from normal means it can happen like this. This image. So this is the incident ray. This is a refracted ray. Look at now where the object is in denser medium and the image is in the same denser medium. So sir, can you say anything about nature? This is a real object and we are getting the real image. This is the real object. We are getting the virtual image. Here for real object, I am getting the real image. Here the real object, but the image is virtual. First case, the object was kept in rare medium and it was facing the boundary such that the boundary was convex towards the rare medium. Here, the same condition. The object was kept in rare medium and the boundary was facing the convex part of the boundary was facing the rare medium. Here object is kept in the denser medium and the boundary what will happen here is facing the rare medium. But look at this one here. Now it will be concave towards the object here. No? Object can be in rarer medium or in denser medium. That's what I mean to say. In all these cases, still that same formula what we derived is applicable. One more. I think one more case is there. I'll introduce that. Geometrical shape, little bit difficult to construct. Yeah, I'll some rough diagram I need. Okay, now you see this. I'm going to keep the object in I'll keep the object in denser medium. Where the center of curvature of this will be here. This is the center of curvature. Now the incident ray moves from rarer to denser. So what should happen to the ray? Should bend towards normal. The ray should bend towards normal. Okay, this is the image. This is a rarer medium. This is a denser medium. So this is a real object and this is a virtual image. That is formed. Okay, this is one situation. Next situation, the object is the center of curvature. Let it be here. The object is kept here. we're in denser medium. So there's an incident ray. Now the ray is moving from denser to rarer. Should bend away from normal. So away from normal will be of like this. So if you produce it back, will come like this. So this is the image. Rarer, denser, this is a real object, virtual image. Okay, now in all the cases, is this formula applicable? Is the formula what we had, what we derived in the previous section, is very much readily applicable. Just you have to use that formula here. So now mu2 v minus u equal to mu2 minus mu1 by r. This is the formula which is applicable in for all these situations. There is no any limitations of this particular formula that it is applicable here, it is not applicable here. Means object is in rare medium, image formed, and object is facing the convex boundary, and the image is formed in denser medium. Is this formula applicable? Yes. Object is in rare medium, and the object is facing the convex surface, and the image is formed in the same rare medium, not denser medium. There is a difference. So is this particular something happened? I'll get it back. Yeah, okay. Now look at this one. Object is in rare medium. It is facing the convex boundary, and the image will be formed in the rare medium. Is this formula applicable? Yes, it is. Now, what is the next situation? Object is in denser medium. It is facing the concave boundary. You can see this concave boundary, and the image will be formed in rare medium. The same situation here. Object is in denser medium. It is facing the concave boundary, and the image is formed, in the same medium, that one. Still, this formula is applicable. Now, what about object? Object is facing the concave boundary, is kept in rare medium, and is facing the concave boundary, and the image is formed in the same rare medium. Similar situation here also. Object is in denser medium, image is formed in the same denser medium. So, and you can see this. Still, this particular formula is applicable. I think you do get conditions like this. So, if this formula is applicable, it's very much. Next, what is V? V is this image distance you should measure from here, from P. This is V. This is U. What about here? What about U here? U is this one. This is U. What about V? V is measured from P. In all the cases, all the distances are measured from P. So in the formula, what you should do? All the distances are measured from the pole, and this is the axis. The direction of incident ray should be taken as positive, and you have to substitute all these things with sign. The use of this formula is all about refraction at spherical surface and the lens. What all we do problems, refraction at spherical surface and the lens is what this particular primary formula. I think I just giving some description. Maybe as when we get into numericals, no, you'll be in a far better position in you how to use this particular formula. Just I wanted to show you, irrespective of whether object kept in rarer or denser medium, object facing in convex surface or concave surface, this formula is applicable. What is mu2? Mu2 is not something like where refractiveness of medium this refractiveness of medium where it will be like this. Refractiveness medium where image is present. No, where the refracted ray is present, that is mu2. Similarly, in this diagram, sir, can you indicate mu2, mu1? Yes, will indicate. What is there in this diagram? This will be mu1, this will be mu2, mu1, this will be mu2, mu1, mu2, mu1, this mu2. Okay, after this we'll go for the magnification formula. Just make observation of these things.